1.1 moles and molar mass. Our outcome is I can calculate quantities of a substance or its relative number of particles using dimensional analysis and the mole concept. So in number one, there's a video here where we want to try to do the math to show how many bags of dog food he's going to need to buy in order to have 1 million pieces of dog food. So he's trying to count the number of pieces in the bag by weighing them. And this is exactly how chemists understand the mole. So chemists count by weighing. 1 mole of sodium contains 6.02 times 10 to the 23rd atoms, and it weighs 22.99 grams. So just like in the dog food video, we don't want to spend all that time counting out that many atoms. So it's much easier to count them by weighing them. So we want to express our conversion factor. So I expressed it the way we would in dimensional analysis as a ratio, and also just as a regular conversion factor. So compare the number of atoms present in 12.01 grams of carbon to the number of atoms present in 26.98 grams of aluminum. And they both contain the same number of atoms. They both contain 1 mole of atoms, as 12.01 and 26.98 are the molar masses of those elements. So we want to calculate the number of moles of atoms and number of atoms present in 10 grams of aluminum. So the first one is just a conversion from grams to moles using molar mass. And then in the second one, I took it one step further and converted moles into atoms. So this is a naturally occurring compound in black walnut trees. It's actually a selective herbicide against competitive plants. Um, so what's the molar mass of this compound? So I've got 10 carbon, 6 hydrogen, and 3 oxygen. So I want to know how many moles are in 15.6 milligrams of this selective herbicide. So I convert milligrams to grams, grams to moles, and then that gives us our answer. Now, reflection questions. It's not possible to count the number of atoms or molecules in a sample. They're just too small, and there's a lot of them. So it would take you the rest of your life and hundreds of years more to try to count to 6.02 times 10 to the 23rd. It's not possible to do in your lifetime. So the mass of this substance is related to how many particles are present because we measure the relative mass of compounds. So instead of counting the particles, we can count them by weighing, just like how instead of counting the dog foods, he can count it by weighing. How does Avogadro's number relate to the number of particles in the sample? So if you have 1 mole of anything, it's going to have the same number of particles, which is Avogadro's number, 6.02 times 10 to the 23rd. And how does the mole allow different quantities to be compared? So the mole is like the general unit that we use throughout chemistry. So in a chemical reaction, we know that we need a relative number of particles of A plus a certain ratio of particles of B to make our product or to make a chemical reaction.